Up until this part of the unit, we've been working on starting with quadratic rules, identifying key characteristics from them, and then sketching graphs to match those rules. In this video, we're going to learn how to do that process in reverse. We're going to start with a graph, and then use some of those key characteristics in order to generate the rule that would create that graph. So our learning targets for this lesson will be to write a rule for a quadratic function given a graph of the function. Our overall goal is to help out the angry birds. Those pigs are at it again. Help the angry birds take those pigs out by determining the course of their path once they are shot from the slingshot. In order to do this, you'll need to take the coordinates provided by their GPS systems to create a quadratic model for the birds to follow. Good luck. Alright, the first example that we'll look at will involve using the x-intercepts and putting it together in factored form. So our first step is to look at the graph and determine the x-intercepts. Then we'll write the factors that would correspond with the x-intercepts in the following form. For example, if our x-intercepts were 5, 0, and negative 2, 0, the factors that would match with that would be x minus 5 and x plus 2. So we would set up a form that looks like this. We'd start with y equals, and then write a, which we're going to solve for eventually. And then our first factor, x minus 5, that goes with the x-intercept of positive 5. And then we'll write the factor x plus 2, which goes with the x-intercept of negative 2. Next is to choose another point from the graph. We'll substitute that point in for x and y, and then use that equation to solve for a. We'll write the final rule in factored form using our original factors and the newly discovered a value, and then we'll check our rule by typing the equation into the y equals on our graphing calculator and verifying that the 3 points that we used, the x-intercepts and the other point, are on the table for that equation. So this is the first example that we're going to look at. The path of this angry bird started at negative 1, 0, traveled through the point 6, 4, and then ended at 8, 0. So we're given our two x-intercepts, and then we're given another point that's on the graph. Our first step is to identify the x-intercepts, which are negative 1 and positive 8. Then we want to use those x-intercepts to set up our general factored form. Since we have an x-intercept at negative 1, one of our factors will be x plus 1. We have an x-intercept at positive 8, which means that our factor that goes with that will be x minus 8. Then we need to have the a in front, which we're going to solve for eventually, and set that equal to y. Now we'll choose another point from the graph. In this case, we're shown 6, 4, so we'll go ahead and use that point. And we'll substitute that point into the rule that we've written. 6 is the x value. So in our rule, everywhere we see an x, we'll replace it with 6. 4 is the y value, so in our rule, where we see y, we'll replace it with 4. That gives me the following rule. 4 equals a times 6 plus 1 times 6 minus 8. The next step is to go ahead and use that equation to solve for a. I'm going to rewrite that equation now and go ahead and do what's in the parentheses. 6 plus 1 gives me 7. 6 minus 8 gives me negative 2. Next I'll multiply 7 and negative 2 to get negative 14. And for my last step to isolate a, I will divide both sides by negative 14. So that gives me this fraction. Our a value is going to be 4 over negative 14. With that information, we can go ahead and write our final rule, going back to our original factored form. So it'll be y equals negative 4/14 times x plus 1 times x minus 8. Finally, I want to go ahead and check my answer using my graphing calculator to make sure that it's correct. So the first thing I'll do is put the rule that I wrote into the y equals, and I can type it in exactly as I wrote it. Then I'm going to look at the table and see if the points on the graph are in my table. So there's the first point, negative 1, 0, and I've highlighted where it shows up on the graph. The next point was 6, 4. I can see where it is in the table and see where it is on the graph. And then the last point is 8, 0. Again, I can see where it is in the table and see where it is on the graph. So all 3 of the points that we were working with show up in the table, which means that the final rule that I wrote is the correct rule. Now we're going to look at an example where instead of using the x-intercepts, we're going to use the vertex and set it up in vertex form. So our first step would be to look at the graph and determine the vertex. Then write the vertex form that would correspond with that vertex. For example, if we had a vertex of 5 and 10, so 5 for our x value, 10 for our y value, then we could set up a vertex form that looked like this, where on the inside of the parentheses we would have a -5, since the x value of the vertex is supposed to be opposite of what you see in the rule. And then on the outside we would have a +10, since the sign on the number on the outside of the parentheses is supposed to match what shows up in the vertex. After that, we'll choose another point from the graph, substitute the point in for x and y, solve for a, and then write the final rule using the a value that we get in our original vertex form. So you can see that really between the two processes, whether you're using factored form or vertex form, the steps are pretty much the same. You're identifying key information, setting up a rule, solving for an a value, and then checking to make sure that your rule is correct. So here's the next example that we'll look at. We're given a vertex of 7, 6, and then we're given another point that's on this graph, 4, 5. So our first step is to identify the vertex. Our vertex has an x value of 7 and a y value of 6. So I'll go ahead and write the rule in vertex form that would match with that vertex. We would have a -7 inside the parentheses, since the x value of the vertex is a +7. And then we would have a +6 outside the parentheses, because the y value of the vertex is a +6. Next, we'll identify the other point that we're going to use from the graph. In this case, we'll use an x value of 4 and a y value of 5. And we'll go ahead and substitute that point into the rule that we've written. 4 is our x value, so where we see x in the rule, we'll replace it with 4. And 5 is our y value, so where we see a y in the rule, we'll replace it with 5. That gives us the following rule: 5 equals a times 4 minus 7 squared plus 6. I'll use that equation now to solve for a. I'll go ahead and put together the number in the parentheses. 4 minus 7 gives me -3. Next, I'll subtract 6 from both sides. And I'll also square the -3, which gives me +9 as a result. Last step would be to divide both sides by 9. And so the final answer for my a value is -1/9. Now I can go ahead and write the rule using that a value that I just found. Y equals -1/9 times x minus 7 squared plus 6. Finally, I want to go ahead and check the rule. I'll start by putting it into the y equals in my graphing calculator, and then looking at the table. So I want to make sure that the 2 points I used from my graph show up in the table. There's our first point, 4 for x and 5 for y. And then there's our second point, 7 for x and 6 for y. Since both of those points show up in the table, then that means that the rule I've written is correct. Now that you've looked at these examples, you're ready to go ahead and try some of the practice ones on your handout. Use this video as a reference as much as you need to. If you need to watch it again, then feel free. That's what it's here for.